Hey, we're here at gotomath.com looking at some calculus. Let's go down to the first derivative test, and I believe we're going to be doing this one here. Ooh, an absolute value. That's not that bad, I promise. Okay, so we got the graph of this function here. I don't know if I told you. So each one of these increments right here is 1 unit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like the critical number is going to occur at 10. And of course, if you plug 10 in right here, you get 0. Right, so the actual vertex of this graph is at 10, 5. So we can just kind of look at that and go, it's at 10, 5 right here. Okay. But did we take the derivative of absolute value functions? I think we did in the rules of differentiation somewhere. I don't know, problems 19, 20 is somewhere over in that area. But let's write this down real quick. Write that down, 5x minus 10 plus 5. Okay, we got that written down. Let's move over to the whiteboard and let's write this up. I've already forgotten it was f of x. Okay, should have known. Okay, so we have f of x is equal to 5x minus 10 and plus 5. So it helps to know, let's say, for example, let's say we had a g of x is equal to the absolute value of x. So if you know what this graph looks like, all you're doing is translating it 10 units to the right, this graph, 5 units up, and then we got this multiplying, we got this coefficient of 5, which is going to make it more of a sharp, I guess you'd want to say sharp point down here, more of a sharper point. Anyway, so you know, it really helps to know what this graph right here looks like. Okay, I mean, you're looking at something like this. Okay, I'm going to try to attempt to draw a straight line. And then what this thing is doing, like I said, it's translating it 10 units, and then we're going up 5 units, right? Okay, and then of course this 5 over here is going to determine whether it's real, right, slender or real wide out like that right there. Well, that's some lovely work going on there. But we're going to take the derivative of this separately. We'll take the derivative of this and then the derivative of this. Now, derivative of a constant is just 0, so forget it, right? And so let's just look at this. So remember the absolute value, you would rewrite the x minus 10. And of course, we just rewrite this 5 like we do in any other derivative. And then you take the derivative of what's inside the absolute value, and that's just going to be 1, and then it's all over the it would be let's see, it'd be all over this piece here, x minus 10, and I guess we could write the 5 out here. But the question is what makes this 0, and of course plugging 10 in. So remember, we would plug our c in right here, so which I didn't do, but c is equal to 10 because that's how we're going to get 0 in the numerator. Of course, if you plug 10 in the bottom, you also get 0. Get 0 over 0. But remember that the 10 must be in the domain of the original function up here. Okay, and it is. It's just not differentiable at the function because we'd get 0 over 0, and therefore it's not differentiable when x is equal to 10. But it is up here. Okay, so c is equal to 10. Pretty simple stuff, I hope. Let's hit it. Let's hit the answer there. Okay, there we go. You know, you really need to know what that graph looks like, and you can skip all that. Anyway, we're at gotomath.com, and I might see you there. Bye.